Hi everybody, welcome back to the YouTube channel Upcoming Cyclone Updates. This is the very detailed weather forecast for the United States in which we'll break down all the things in detail and cover all the things. If you're new to this YouTube channel and still haven't subscribed, so subscribe now so you don't miss any important weather updates. Thanks a lot. Thunderstorms are expected to persist over the Ohio and Tennessee valleys and extend into the central and southern Appalachians at the start of the work week. This ongoing weather pattern is driven by an active upper-level setup, which features several shortwave disturbances and an approaching surface frontal system from the west. These meteorological factors will help to trigger and sustain storm development in these regions through the night. As this system progresses, it will bring substantial moisture, which is a key ingredient for heavy rainfall. This abundant moisture will enhance the potential for heavier rain rates and increasing storm coverage into the evening. The likelihood of back-building and repeated rounds of storms will also elevate the risk for locally significant rainfall totals. As a result, the Weather Prediction Center has issued a slight risk of excessive rainfall, level 2/4, indicating a scattered threat of flash flooding in these areas. In addition to the rainfall threat, the Ohio Valley will experience sufficient atmospheric instability and wind shear to support the development of a few intense storms. These conditions may also lead to the formation of a more organized storm complex later in the evening. The Storm Prediction Center has therefore included a slight risk, level 2/5, for severe weather, primarily due to the potential for damaging winds. This active weather pattern will continue into Tuesday, with the focus of storm activity shifting further into the southern and central Appalachians. As the upper-level energy and surface frontal system move eastward, another slight risk of excessive rainfall is in place, signaling additional instances of flash flooding. Beyond the primary flash flooding threat, scattered thunderstorms with moderate to locally heavy rainfall are expected to occur more broadly across the Midwest and Southeast on Monday. Rain chances will expand into the Mid-Atlantic and Northeast as the system approaches from the west on Tuesday. High temperatures across the eastern United States will vary depending on the extent of cloud cover and storm activity, generally ranging from the mid-80s to low 90s. Further west, additional thunderstorms are anticipated along the frontal boundary extending into the upper Midwest and northern plains. Embedded upper-level energy will help to trigger one round of storms over the northern plains today. This region will experience stronger upper-level flow, resulting in more pronounced deep-layer shear compared to areas further east. Consequently, another slight risk of severe weather has been issued, primarily due to the threat of very large hail and significant damaging winds if storms consolidate into an organized system later in the evening. Another round of severe weather is possible downstream over the upper Midwest on Tuesday, as yet another upper-level disturbance helps to trigger storms along the frontal boundary. Very high moisture levels will lead to strong to extreme atmospheric instability, with a slight risk in place for the potential of more damaging winds. While severe weather remains a significant concern, heat will become a major story across the central United States over the next few days. An upper-level high-pressure system is expected to strengthen and expand over the region, leading to soaring temperatures. Highs on Monday and Tuesday are forecasted to reach the triple digits in the Central Plains, with temperatures in the upper 90s to low 100s over much of the High Plains, and mid to upper 90s in the middle and lower Mississippi Valley. High humidity levels in the Mississippi Valley and eastern portions of the plains will result in heat indices ranging from 105 to 110 degrees, potentially reaching as high as 115 degrees in some locations. This oppressive heat has led to widespread issuance of heat-related warnings and advisories. Overnight lows in the mid to upper 70s will provide little relief from the heat, exacerbating the overall discomfort and health risks. This combination of hotter temperatures, higher heat indices, and the multi-day duration of the heat wave will increase the danger not only to more sensitive groups but also to the general public, particularly those without adequate air conditioning. In contrast to the heat in the central U.S., a stagnant troughing pattern over the western United States will keep temperatures mostly below average, especially over portions of the Pacific Northwest and the northern Great Basin, Rockies. High temperatures on Monday and Tuesday will range from the 60s and 70s along the Pacific coast, 70s and 80s in the Pacific Northwest and northern Great Basin, Rockies, 80s and 90s in interior California and the central Great Basin, Four Corners region, and 100s in the desert Southwest. A cold front moving through the Pacific Northwest will bring some rain chances on Monday, which will spread into the northern Rockies on Tuesday. However, the precipitation is not expected to be significant enough to alleviate ongoing drought conditions in some areas. Smoke from regional wildfires will continue to plague parts of the West, particularly over portions of the northern Great Basin, leading to poor air quality and reduced visibility. As we delve deeper into the details, it's important to understand the meteorological factors driving these weather patterns. The active upper-level pattern responsible for the persistent thunderstorms in the Ohio and Tennessee valleys, as well as the Appalachians, is characterized by a series of shortwave troughs. These are small-scale disturbances in the mid to upper levels of the atmosphere that can enhance upward motion, leading to cloud formation and precipitation. The approaching surface frontal system acts as a catalyst for storm development, providing a boundary along which air masses with different temperatures and moisture content converge. The presence of plentiful moisture in the atmosphere is a critical factor in the heavy rainfall threat. When warm, moist air is lifted along the frontal boundary, it cools and condenses to form clouds and precipitation. The process of condensation releases latent heat, which further fuels the upward motion, enhancing storm development and intensifying rainfall rates. This is particularly concerning in areas prone to flash flooding, where the terrain can exacerbate runoff and lead to rapid water level rises in streams and rivers. The risk of back-building or training storms adds to the flash flooding threat. Back-building occurs when new storm cells form on the upwind side of an existing storm, causing it to remain stationary or move very slowly. This can result in prolonged periods of heavy rainfall over the same area, significantly increasing the risk of flash flooding. Training refers to the movement of multiple storm cells over the same location in quick succession, similar to the cars of a train passing over a single track. Both phenomena can lead to substantial rainfall accumulations in a short period, overwhelming drainage systems and natural waterways. In the Ohio Valley, the combination of sufficient instability and wind shear creates a conducive environment for severe thunderstorms. Instability refers to the tendency of air parcels to rise, which is often measured by parameters such as convective available potential energy CAPE. Higher CAPE values indicate a greater potential for strong updrafts, which can support the development of severe weather. Wind shear, on the other hand, is the change in wind speed and direction with height. It helps to organize thunderstorms and can lead to the formation of supercells, which are capable of producing large hail, damaging winds, and tornadoes. The potential for a more organized storm complex later in the evening is particularly concerning. These complexes, known as mesoscale convective systems (MCS), can cover large areas and persist for several hours, causing widespread wind damage and heavy rainfall. The Storm Prediction Center's issuance of a slight risk for severe weather highlights the need for vigilance and preparedness in the affected regions. Moving into Tuesday, the shift of storm activity further into the southern and central Appalachians will bring similar risks. The mountainous terrain in these areas can enhance the flash flooding threat, as steep slopes facilitate rapid runoff and can lead to swift rises in river levels. The continuation of a slight risk of excessive rainfall underscores the persistent threat of heavy rain and flash flooding. Outside the primary flash flooding areas, scattered thunderstorms with moderate to heavy rainfall will be more broadly distributed across the Midwest and Southeast. This widespread storm activity is a result of the expansive influence of the upper-level pattern and surface frontal system. As these systems move eastward, rain chances will increase in the mid-Atlantic and Northeast. The variability in high temperatures across the eastern United States will depend largely on the extent of cloud cover and storm activity, with areas experiencing more sunshine reaching higher temperatures. Further west, the additional storm activity along the frontal boundary in the upper Midwest and northern plains will be driven by embedded upper-level energy. These regions will see stronger upper-level flow, resulting in more pronounced deep-layer shear. This environment is conducive to severe thunderstorms capable of producing very large hail and significant damaging winds. The potential for storms to consolidate into an organized system later in the evening further elevates the severe weather risk. The heat wave in the central United States is another major concern. The strengthening and expansion of the upper-level high-pressure system will lead to soaring temperatures. This type of weather pattern, often referred to as a heat dome, traps heat near the surface and can result in prolonged periods of extreme heat. The forecasted high temperatures in the Central Plains, High Plains, and the Middle and Lower Mississippi Valley are indicative of a significant heat wave. High humidity levels will exacerbate the heat, leading to dangerously high heat indices. The heat index, which combines air temperature and humidity to reflect the perceived temperature, will range from 105 to 110 degrees, with some locations potentially reaching as high as 115 degrees. This oppressive heat has prompted widespread issuance of heat-related warnings and advisories, highlighting the potential health risks. The combination of high daytime temperatures and warm overnight lows in the mid to upper 70s will provide little relief, increasing the risk of heat-related illnesses. In contrast, the western United States will experience below-average temperatures due to a stagnant troughing pattern. This pattern will keep temperatures cooler, especially in the Pacific Northwest and Northern Great Basin, Rockies. High temperatures in these regions will range from the 60s and 70s along the Pacific coast, 70s and 80s in the Pacific Northwest and Northern Great Basin, Rockies, 80s and 90s in interior California and the Central Great Basin, Four Corners region, and 100s in the desert Southwest. Thanks for watching.